In this video, we'll be having a look at the following linear algebra problem. Suppose S is a subspace of four-dimensional space and which is spanned by the vectors u equals 1, 2, 2, 3 and v equals 1, 3, 3, 2. Find two vectors that span the orthogonal complement of S. So these are two vectors that span the subspace which is orthogonal to S. Before we have a look at the solution, if you like, you can go ahead and pause the video and have a go at trying the problem yourself. Okay, let's have a look at the solution now. We must solve the following equations: u dot product with w equals 0 and v dot product with w equals 0. And we need to solve this for the vectors w in the four-dimensional space. So we need to find two linearly independent vectors that span this orthogonal complement. So what I'll do is now I'll make the matrix, the 2x4 matrix A, and the rows of A are the vectors u and v. This means using these two dot product equations, it means it's equivalent to solving this matrix A times the W vector is equal to the 0 vector. So that's, oh wait, it's a slight error here. I should say it should say 0, 0 here. There's two zeros. So we need to solve AW equals 0 for the null space, define null space of A. And just do one row operation here to change this 1 into a 0. So we're doing row 2 equals row 2 minus row 1 to make a 0 on the bottom left. And that's the only row operation we have to do here. So now we have two equations. So using the second row, we have W2 plus W3 minus W4 equals 0. So now we can write W2 as equal to W4 minus W3. So we're using back substitution here. And now first row over here gives us W1 plus 2W2 plus 2W3 plus 3W4 equals 0. So now we can write W1 in terms of the other one. So W1 is equal to negative 2W2 minus 2W3 minus 3W4. And since we found W2 in terms of the other two variables here, we can now substitute W4 minus W3 here. And this will give us minus 5 times W4 for W1. So this means our vector W is equal to all these two values we substitute here and W3, W4 here. So now we can write this in terms of W4 and W3 like this, and times two vectors here. And for any W4 and W3, we have a working solution for W. This means we have two linearly independent vectors, the minus 5, 1, 0, 1 and 0, minus 1, 1, 0. These span the solution set for W. This means these vectors span the orthogonal complement of S. So we just have two vectors that span the orthogonal complement. So that subspace is orthogonal to the original subspace S. Okay, so that completes the solution to this problem. Hope you enjoyed this video. Thanks for watching, and I'll see you next time.